This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Go first.
I'm Aiden Stigora, also from 2472.
Yep. I'm Sawyer Tice from 2472.
I'm Audie and from
Don Johnson from 2472.
Dustin Early from 3102.
Sam Bieselman from 2847. We'll have a couple others here too.
Jesse Frost from 3134 and 3275. And we do have a driving Swerve Drive that we just got going. So interested to learn more.
Okay. I'm Eric Schaefer from 2502. We just put together a Swerve Drive 2.
I'm Andy, also from 2502.
I'm Will from 2239. We had a Swerve Drive last year.
Hello, I'm Rasmus. I'm from 2491, and we made Swerve over the summer.
Anyone else? Anyone else want to share their team before we get started? I think Alex just joined us. Alex, what team are you with?
I'm with team 3102.
Oh, we got one more person. Hello, Isaac.
Kedrick from 4674.
All right. Anyone else want to share their team number? Otherwise, we'll kick it off. All right. Again, my name is Scott Davis. I'm a mentor with 2052 Nightcrawler. And tonight, the goal for I will say that I'm attempting to record this. So whatever you say will be on the recording. Fair warning on that. I think our agenda for tonight is to keep this really open. I'm going to have Matt, who's our programming captain. He's going to start off with sharing our story of what we did for Swerve and the challenges we encountered, advice we have. And I know talking to Matt, we have questions too. So I'm looking forward to seeing what the other teams are doing with Swerve, because I know we want to do some things differently this year. So after Matt gets done sharing his story, anybody else that has some advice they want to share, we want to open the floor up to everybody to share their story of how their Swerve experience went, either last year or over the summer or whenever the last time you did Swerve was. And then we'll just do a general Q&A. I anticipate this will go an hour. It might go more, it might go less. I don't really have a hard stop, but I really would rather not be here at 9. So go ahead, Matt. Why don't you kick us off?
All right. Feel free to step in if I forget anything or anything like that. But we started our Swerve, let's see, it would have been not this summer, but the summer before that. Kind of started as a summer project to see if we'd want to use it as a team. So building it, I don't believe we ran into too many difficulties actually assembling it. We had a lot of trouble getting it up and running with code though. And usually I think at first the biggest problem, we had it working with teleop, and then our autos weren't working. So our odometry wasn't tracking right or something. And we'd fix that, and then the teleop would stop working right. And it was a mess going back and forth. And we were trying to use 100% WPI lib. And we had a really hard time finding good, solid documentation on how to make Swerve Drive, and then also working with autos in Swerve Drive. So that was probably one of the biggest challenges we faced, and we ended up switching to SDS, the SDS Swerve library, and we found some success with that. But we also ran into some problems with that, such as like the dead wheel problem, where for the first 10 seconds after our robot had booted up, the wheels weren't in alignment with each other. And so we had to wait 10 seconds every time we boot up our robot at the moment. So, I mean, that's kind of where we're at right now. That's our working Swerve. We also had some problems with the WPI lib. Their auto example that they use is very just like do a S curve. It doesn't take into account actually rotating the frame of the robot or anything like that. So we had some trouble figuring out how that worked, because that's a whole nother aspect of autos, is making sure your robot's facing the right direction for what you want to be doing. And so we had a pretty hard time figuring that out. We ended up getting that working though. And yeah, at the moment we're trying to move away from the SDS library and go for 100% WPI lib, just so we're not relying on third-party libraries for a really crucial part of our code. And then we're also hoping to fix our dead wheel issue with that. I think that's kind of where we're at right now.
Matt, I'll add a couple of things too on the build side. One of the things that we struggled with at 10K was the defense. We were taking a lot of defense. We were very scared about our Swerve Drive being damaged. And in fact, we did get a Falcon knocked off of our Swerve Drive. We were using the MK3 model from Swerve Drive Specialties. So the motors were up in the air above the bumper. And we had a Falcon ripped off one of our Swerve modules up at in Duluth. And so we put on churros to sort of protect them, but they weren't great protection. Next to us were the Hilltoppers, and they were actually our alliance partner in finals as well. They did something super brilliant that I'm telling every team doing Swerve. If your motors are going to be up above your frame, what they did is they put 1/4-inch polycarb in the corners, and then they built their frame so that their bumpers, the polycarb was sandwiched between the bumpers and the frame. And so they figured their frame and their frame perimeter and such that they could put a 1/4-inch polycarb in the corners all the way around, and there was no way they were going to take damage on their Swerve modules. That was super brilliant. It's a totally an idea we're going to steal. If we ever do Swerve above the frame, we have ordered the MK4 inverted for this year, so the motor should be protected inside the frame.
You said you put, I'm sorry, you said you put polycarbonate around like the motors and the wheels and everything, or where?
In the corner. So in the frame corner, we put polycarb. They did. We didn't. The Hilltoppers did this. They're out of Wisconsin, Milwaukee, I think maybe. But in the corner, they had about a 6-inch piece of polycarb in each corner on the corners, and it went up, and that way, it would take any. And because polycarb flexes, but then always goes back to the way it was, it would take a bit of damage or a bit of impact without hitting the motors. So it was super smart. Oh, Sam, did you just share a photo of that? You might. That sounds like something. No.
Yes, I did.
That didn't link. That link
didn't. And that didn't
work.
work.
Sam. No.
Nice. Okay.
Anyway, so the search for Hilltoppers. Look at their Swerve motors. They had this really cool thing. That was not something we thought about ahead of time. And because we built our frame to the frame extents, we couldn't add that on later and make our bumpers bigger. So by shrinking the frame a 1/2 inch each way, we would be able to put on the polycarb. So that's a really important piece of advice that I'll share with all of you, that it was a brilliant design, and we're going to steal it if we have to use our old MK3s, because the MK4 Swerves don't arrive in time for us this season. The other thing I'll share is shorten your CAN wires, solder your CAN wires. I recommend putting your Swerve the first 12 things in your CAN bus. Make sure Swerve is the first ones so that if a break happens down the chain, you can still drive. I don't know. I think that might have been all the advice that Matt didn't cover.
To add on, Scott, so we had a different issue. We had the CAN wires ripped out of our Falcon, at the Falcon. So there's no wire sticking out by another team, right? And so that meant we having to change the entire Falcon out in between matches. And so similar idea, right? Any wire that's sticking out, right? Even if you don't take a hard impact, it's pretty easy for it to get caught and ripped out. So you get those covered as much as possible. And I've seen a number of different things, like you said with the Hilltoppers, to cover those motors sticking up. Right. The nice thing about the Mark IVs and the Mark IIIs or anything with the motors sticking up is that it takes up less space inside your drivetrain. The downside is the chance of impact, because they're so much higher than the bumpers is much higher. Although I think partially it was really bad last year because the size of the balls was greater than the diameter of the balls was greater than the height of the bumpers. And so intakes were sitting over the bumpers. So if we see a game this year where intakes sit below the bumpers, we might not see the same level of damage coming out between, but still worth it to cover them.
Yeah, I don't know. I feel like damage, we're taking more and more damage every year. I think I have this little soapbox I stand on that the first rules incentivize high contact for robots. There isn't a downside for someone playing defense with all of their stuff inside their robot. So I don't know. I feel like we're taking more and more damage every year. A couple other things. I did find my notes here. On the dead wheel issue, I know that Matt mentioned the dead wheel issue. There's a huge long thread on Chief Delphi. I was part of that thread about the SDS dead wheel. The way we overcame that was we would power on a robot tethered on the cart while we're in queue. We would turn on tally app, wait 10 seconds, make sure all the wheels click to show they're initialized, and then we would leave the robot powered on while we put it on the field. I know that a lot of people, there are people that don't like that the robot is powered on when it goes on the field. In fact, some field judges will tell you have to turn your robot off before you put it on the field. That's not true. It's not in the rules. It is safer, and clearly it's a better way to do it for safety. But when the option is that you can't run auto, we we did it that way. They may change that rule. We're really hoping to avoid this dead wheel issue altogether with new code. But that was how we overcame this dead wheel issue last year, is by having the robot powered on before we put it on the field. The other thing I'll say too was we think our issue with why we couldn't get WPI lib to work last year was somewhere in our code. We had a units problem, degrees, radians, probably. We just couldn't track it down. We could not figure out where we were having a conversion issue or what the case may be. It could have been a gear ratio issue. We just never were able to track it down. But we did find that one of our many problems we had was that we were mixing degrees and radians and we weren't converting them properly. So that's a tip I'll share as well, is be very careful with your units. I don't have anything else. Matt, should we move on?
Yeah, I was just gonna say this year, we're trying to go with like all, or at least when I'm rewriting the code, I've been going with all either rotation 2Ds or radians is like just the standard. That's what I'm like, setting a standard of what you're going to use is really helpful.
Okay. Anybody who else has had some advice that they want to share? Feel free. Anyone.
I don't have any advice. I've got a list of questions, so I defer to anybody who has advice first, and then I can kick off questions if we're ready.
I got a quick question. Was that dead wheel problem just during an autonomous routine, or is that during teleoperated too?
It's always so. Almost every time, and I would say 80% probability, if you deployed code or you had just powered on your robot, you were going to see at least one, and it wasn't always the same one, but you're going to see one wheel where the CAN coder failed to initialize. And so its zero was the absolute zero. It wasn't the offset zero. And so it would drive in a different direction and drag. We called it dead wheel. It wasn't that it was dead. It was just driving in the wrong direction. And so you were dragging it across the carpet.
We haven't experienced that. Did it correct itself throughout the match?
If you let it sit for 10 seconds, there's a inside the SDS, and now this was using the SDS library. Inside the SDS library, if the chassis sits idle for 10 seconds, it does sort of a self-check or a reset, and all the wheels would sort of chatter, and they'd be all lined up. And so we followed the advice on Chief Delphi of how to fix this issue, and none of the things that we tried worked for us. Part of the problems with the SDS is, well, the benefit is it's super simple to use because they have, if you're using Falcons, use this code. If you're using Neos, use this code, and then you're set. And so the setup is super trivial. The hard part or the bad part about that is that everything's abstracted so far away you can't even get to the
Yeah.
objects that are making up your swerve, and so you had to pull down their source code and bubble up these can coders to try to rerun the initialization yourself when you're in disabled or you're in test mode or whatever you were running in, and we just couldn't get it to work. So that's why Matt said we're trying to be pure WPI lib because that will give us access to all of the objects and give us a better chance of
Are you running
these
Neos or
things.
Falcons?
We were running Falcons last year. We're running Neos. We're planning to run Neos this year, assuming that our new Swerve modules show up.
Because
So
we
with
haven't got a lot of miles on ours, but I haven't experienced that issue with Falcons and our MK4s on our chassis that we did this fall.
I don't think the issue was with the motors at all. I think it was with the can
coders.
Yeah, we're using the can coders too. So
yeah,
Interesting.
And other teams on Chief Delphi have said, including the team that backs SDS. I don't know how that association works, but they're like, we've never seen this. We can't reproduce it. And other teams are saying the same thing, that they had never seen it, but there were a number of teams like us who were seeing the issue.
Weird.
So who knows? Maybe it'll be gone and we'll never see it again. Maybe we got a bad batch of can coders. I have no idea.
I've seen it happen too, and I followed that thread and did a couple additional changes. It still happens. I think it'll reset even if the robot is disabled. So at least that's a good thing. If you put your robot out on the field and let it sit, hopefully it'll resolve itself. You don't have to power it on in queue, but it's best if you power it on in queue, I suppose, and enable it like you're saying. Then you can confirm that it's going to work. I like that.
Well, my concern is the loss of 10 seconds if we power on the field. So that's something that has me the most concerned about this bug. So
Yeah, and this is only with can coders, right? So like if you choose a different ecosystem, then you don't necessarily have to worry about it. The other thing I would caution with SDS template code is that so far they haven't rewritten it to be compatible with 2023. So, and there's a lot of chatter around, how well maintained the library is. I would highly recommend, if you're planning to use template code, to try to steer away from SDS.
That is a great point. In fact, last year they had the same problem where the library hadn't been updated, and it wasn't updated until I think week 4. And so we were struggling with WPI lib for 2 weeks, and then the SDS library got updated and we switched and everything just worked, other than this dead wheel issue. So to Matt's point earlier, we're really trying hard to get everything working on WPI lib and understand that library set better.
So I know, has anybody been following the Rev Robotics programming or code release that they're coming out with for Swerve Drive? Anybody aware of that? Okay. Anyway, I know I've been talking to Greg Nadell, and I would say first week of January, most likely, they're going to be dropping code resources for Swerve. The impression that I've gotten from a number of people who've run SDS library Swerve drives in the past is echoing the sentiment here, is that it's kind of subpar, or that there's a lot of room for improvement. The beta teams that I've talked to who have run the Rev programming library, that being 4481 and 2363, they've got the beta modules for the Rev Swerve. They've given me a little bit of hope that the Rev libraries are going to be, a drastic improvement. And talking to the people that I know that work at Rev, they're also pretty confident that, the Rev libraries are going to make programming a Swerve drive easier. From my perspective, I'm kind of banking on that, because we're coming into the year. We ordered the Rev Swerve modules, the minute that they were released, and they're going to be shipping like 3 days before kickoff. So we're essentially going into the year with no Swerve experience, with the goal of building and using a Swerve for the 2023 game. So I've heard good things about the library. I am not a programming guy. Just I hear things through the grapevine. But that's, I guess, what I know about that right now.
Do you know if that? Oh, sorry. Go ahead.
I was gonna say same here. We're doing the exact same thing, trying to go all in on the Rev thing, and we'll see how it goes.
Do you know if the is that Rev library specifically for their modules, or is it like a general Swerve library?
I don't think it's specific to their modules. I also don't think it's specific to Neos only. I think they're going to have a configuration for Falcons, though I don't know that for sure. I am pretty confident that it's not specific to the Rev modules, though.
I have another question. We're ready for another one. You mentioned making sure your CAN wires were short and everything. Has anybody used a Canivore? We have our practice drivetrain set up and we didn't, but we ordered a couple. Not sure if that's going to improve things or what people's experience is.
We ordered one partway through the season last year as a necessity. We were approaching the point where it was becoming a problem. We weren't, I don't know, Will can chime in maybe a little more. I don't know that we were on the edge where very occasionally we saw things that looked like it could have been a problem related to overutilization of the CAN bus. And we decided to just buy it and make sure that wasn't it. To be fair, we were basically using all CAN devices for all of our associated actuators, right? So, but it was definitely worth it if you're throwing Falcons and CAN coders on there to get all 12 CAN devices on there. So we just ran the Swerve drivetrain on its own Canivore with that CAN chain sitting exclusively in the drivetrain, and it never exited out of there, so that it had minimal chance of getting caught and pulled out. And then everything else was on a separate CAN chain.
We purchased one as well. We ended up not using it. It made a lot of the mentors very nervous to have the most critical part of your robot on a USB device. We take a lot of impacts during a match, and we were very concerned that the one thing you don't want to lose is your drivetrain, because you can at least play defense. It would be nice if that Canivore could run everything else, but it only works with certain devices. I don't think it works with old Talons and Victors. So if we could put everything else on the Canivore, like your shooter and your intake and stuff, and your air compressor, and then use the built-in CAN for your chassis, we probably would do it. But I don't know. We got really nervous about putting our drivetrain on a USB plug. We just weren't comfortable with that. What we did do instead, though, because we were pushing the limits on CAN traffic, especially during initialization, which very well may be why we were having dead wheel issues, we put all of the initialization of all of our other CAN devices on a delay. So we would new up our drivetrain, and then we wouldn't initialize the other devices it was either until auto or teleop had started or until 10 or 20 seconds had passed. So we had worked with the kids to implement codes so that we would only new up the drivetrain initially when the first chance we could, and then we would new up everything else after some type of a delay. And we are still having dead wheel issues.
Yeah, we have just a drivetrain and we have the dead wheel issues. Like it's something with the CAN coders, definitely.
Did you guys ever run into problems when using the Canivore with like disconnecting or losing the connection at all?
No, but we also spent a decent amount of time running that specific USB cable between the Canivore and the Roborio, and where that was positioned and how we strain relieved it and how much hot glue we applied to different things. And we're fans of hot glue. We have one mentor who owns several cordless hot glue guns. And so if you have Ryobi tools, you should buy the cordless hot glue gun. Hands down, best investment, $20. But anyway, so yeah, that one wire specifically, we moved a few things intentionally to put that in. And yeah, we played with it a good amount, Scott, to feel it out for what it should be. I think we ended up buying a different cable with a right hand or a 90-degree connector to come out and then run over, because it's if I remember right, it's a USB-C on the Canivore side and USB-A, so you can run a different cable if you want, right? You can get your own and run it, which might be worth it. So.
All right. Shifting gears a little bit, I heard from Sam that Sam is in the same boat that I am, where, our team is going in with no off-season experience on our Swerve Drive. Is anybody else in that boat? And for those of you who are not in that boat, who have more experience, how crazy are we? Do you think we've got a shot?
Yeah, we're going in the same way. This is Ken Mechtel. We're going in with, we just got our Swerve Drive moving around, so we're actually planning a backup strategy just in case. We're actually building a thought process right now is to build this second frame so we can convert back to tank drive if we need to. The challenge is there. The biggest challenge we have right now is Falcon motors. We don't, we've got enough for the robot right now, and which makes me extremely nervous, but especially after hearing about people's motors busting off their off their Swerve Drive units, that makes me really nervous. So,
Ryan, I will say that Nightcrawler did Swerve over the previous summer, but all we did was teleop and the WPI sample auto, which did not rotate the robot. We got it to work. I'm like, okay, we proved that we can do this. That was a mistake. So we should have spent much more time, especially with the auto. For those of you, I know it's kind of late at this point, but do a real auto where you're driving back to a corner and spinning around while you're driving and prove that you can do that. We didn't do that. And so we didn't get our Swerve Drive working until week 4, and we were still able to have a good season with good autos. So if you get your Swerve Drive put together by week 2 or 3, I think you have the potential to be fine. Obviously, having it a year in advance would be way better, but it's not impossible. We kind of felt like we were behind the 8 ball last year because we waited so long to prove out, to find some of these mistakes. But in the end, it actually ended up working out for us.
Okay. Yeah, I mean, we're sitting with, ignore the elevator, that's me playing around, but we're sitting with basically this right here in our shop minus the modules. We're just waiting for the modules to get shipped. We're going to bolt them on. We're hoping to get it, early the week before kickoff. We're going to bolt the modules on in an hour. We've got code, theoretically ready to go. And, within an hour after we get the modules assembled, we're hoping to test it out. So I don't know that we're in a terrible spot. I feel fairly confident that with the programming resources we have, that we'll be able to get something driving at a base level within the first week after kickoff. At least that's the hope. But yeah, I don't know. It'll be interesting.
And that's also you using the Rev library, right?
So currently, I think I'm not a programmer by any means. I believe that our student programmer is using the SDS library with the idea that once the Rev documentation drops, we're going to be converting everything to the Rev library, utilizing that however we can, and kind of going forward from there.
So Ryan, I'll say that we bought our Swerve modules intending to get them in June. Did not get them till mid to late September, and then assembled the drivetrain, and then worked through it well building robots for turtle trials and training in rookies because our team was down to 6 students or 7 students going into last year, right? And so we did all right. Our decision, we were shooting for looking at it and going before the beginning of the school year was our goal of having it together and saying, can we drive it better than we drive a kit parts drivetrain? Right. And if yes, then we'll move forward. If we can't, then let's just do kit parts, right? And keep going with that. In the end, because we didn't get them until late September, right? Our whole timeline was blown out of the water, but we decided to go anyway. I would say by about this time, we were on par, maybe slightly ahead of operating it versus the kit parts drivetrain. To Scott's point, I don't know that we were really effectively utilizing any of the advantages. But the thing we looked at and said was, it's comparable to the kit parts drivetrain, so there's no downside there, right? In terms of how we felt we could use it, and there was lots of upside potential. But one of the big things for us is that we haven't historically been a mechanically strong team, and so having much clearer, easy ways to mount things to the frame versus the kit parts drivetrain was a big win for us. Right. So doing Swerve actually made our mechanical aspects easier for us, which I think is an undersold aspect.
Yeah, I mean, like my initial impression about the mechanical, nature of putting together a Swerve drive is that you can put it together in about a third the time that you can a tank drive, and you've got a lot less machining. Finesse is a lot less restrictive. And by that, I mean, you don't have to get perfect center to center for your chains, for your belts. Everything is, contained within the module. And being that in the modern era of FRC, all the modules are, current off the shelf components, they're machined by professionals. And generally, I think the quality of the modules is pretty high. To be determined for the Rev modules, but everything I've heard about the STS modules has been, very, very high praise is what I've heard.
Yeah, they're pretty nice.
Ken, I see you had your hand raised. You don't have to raise your hand. Just whenever there's a lull, ask a question. That goes for everybody.
Oh, I'm just a little bit confused. I don't know what Rev means. Like, you guys are talking about like Rev libraries and stuff. I don't know what that is.
Yeah, so Rev Robotics is a company just like AndyMark or Vex Robotics. And Rev Robotics this year came out with their own Swerve module. And along with that Swerve module, their goal was to make Swerve Drive a little bit more accessible for teams. And so they're going to be publishing a bunch of code resources dedicated to making Swerve Drive easier.
Oh, that seems cool.
Definitely.
Yeah. Thanks.
I had a question with your initialization routines, because it seems like most of the people here have it set up so that during auto or whatever, it can automatically align the wheels. But in my experience, all of our encoders reset to whatever the power on state is. So what sensors are you using to align your Swerve modules?
You have to use a mag encoder. So the CAN encoder is a magnet encoder. When you the way that it works is that you put the magnet in the Swerve module shaft, and so magnetic north is then sort of identified. And so part of your setup configuration process is you either take a square or you take a level or something long that you can line up the wheels so that pointing straight ahead, and then you read where is magnetic north. And so let's say that magnetic north is 28 degrees to the left. Then you apply a 28-degree offset. I don't remember if it's positive or negative, but then in your code, what you have to say is that straight ahead for the front left wheel has an offset of 28 degrees. So unlike regular encoders where every time you power cycle it, it's back to 0, magnetic encoders use the magnet so that magnetic north it never changes. And so that's the difference between encoders that go on a Swerve drive versus regular encoders you'd put on a motor. The ones that go on a Swerve drive, you have to use a magnet encoder so that north is always the same.
Yeah, I can show the code on that if you want me to.
Sure, go ahead, throw it up, and then I'll make it.
And there are other absolute encoder types, right? So absolute encoder means that you always know its orientation even after it powers down.
We're using the ones from the SRXs.
And many of the encoders in first can be used as absolute or relative encoders, but how you wire them can potentially change, or what type of wiring you can use. So double check that you are wiring for absolute encoders.
I think also what the SDS library does and what we're trying to do this year is we set our encoders. So we set our steer encoders to the CAN coder value when we initialize it. So when we initialize everything, we get our CAN coder value, whatever it's pointing at, and that's what we're using for our starting position on our steer encoder.
I don't know if this helps anybody, but I mean, we just did some math to orientate them to be all facing in a very similar direction. Like you said, with a level basically, and taking some notes, but that's how we got it to everything facing in the right way.
That brings to mind another question. The SDS library uses the CAN coder to set an offset on the Falcon, and then it uses the Falcon encoder for the rest of the time. I had some discussion on Cheap Delphi with other people about whether they do that or not. Just curious what other people think. One of the downsides with the SDS is, there's lash in the belts. So if you don't use the CAN coder, it may not be as accurate. Does it matter? Have people had any experience one way or the other?
For the Stampede, we do use that the CAN coder offset, feed it to the motor, and then we drive the rest of the match with the motor. We had zero issues with it. It's actually a little bit more snappy because it's resident to the motor itself, so you can run a higher PID, and it just it's very mechanical. It's very good. It's very snappy.
Yeah, it seemed, latency wise and programming wise, that's the best way to go. But then somebody pointed out that mechanical aspect of if there's lash in the belt, that the motor, is going to turn before the wheel or, snap, whatever. But does it? I don't know. I don't think it matters. It doesn't need to be that accurate in FRC that it probably matters. So
yeah,
better to have the faster read time than to be slightly more accurate.
Yeah, I think either approach is good enough. And when we did hit those times, we didn't call it a dead wheel, we called it a janky wheel. So whenever we hit those janky wheel matches, we would just turn off the seating of the motor and re-get the absolute position to fix that issue. So we spent enough of Great Northern with matches that were like, oh crap, not this again, to the point where we fixed it in the code to re-get the absolute position of the magnet to fix the match.
Did you just do that on timing, kind of like the SDS library, or did you put a button somewhere that somebody could push?
We put a button.
That's a good idea. I'm going to take a note.
So you guys just had a button, and then it just got the absolute encoder values, and then fed it right back into the motor as the new position.
Right.
Yes.
I have potentially a question. So we've been working with, so we use C++, so we haven't been able to use the SDS library, but we've been using basically custom, and then we just push the PID off onto the Falcons themselves. We've been running into an error where basically the Falcons, when we get the PID fast enough that they snap to position, they have a bit of play around their target value where they won't fight back. Do you have any ideas on how to fix that?
You might want to first check, you probably already did this, but you probably want to first check the deadband on the motor itself. The deadband on the Falcon motor could be, however many degrees to the point where you do have that play. That's the only thing that comes immediately to mind.
Yeah, we set that to oh, okay, I think I'm unmuted. Yeah, we set that to a value that would have been around 1 degree. And it still had like 10 degrees of play on either side.
10 seems like a lot. Are you doing this with the robot sitting on the carpet, or are you doing it with it up on blocks to see that the wheels are
Either way, it just was willing to
even without any
turn
weight,
that far
without
before it would fight back with the PID.
oh, so even without friction on the carpet and all that pressing back, you were still having that problem.
Have you tried upping your KP value?
If we do that too far, then the D has no effect.
Do you need a D? Like we run just a KP feedback loop for our turn motors.
I think
we
so.
might not
run
need
into oscillation otherwise.
I mean, I guess that's something I would suggest is like trying to take the D out, see if you can get it not to do that kind of deadband thing with the P. Like it's better to have like see if you can get it just to oscillate, but be the way you want, and then see if you can just kill the oscillations. I mean, maybe you already did that. I don't know. That's kind of like the standard. I guess that's what we've always kind of tuned it is get the feed forward going pretty close, then the P, and then see if you even, do your best to not need anything else, basically.
Yeah.
And keep those terms tiny. But
yeah,
it's,
All
I'm
right,
sure you
thank
tried
you.
a bunch of that too. Yeah.
There is also the tolerance or the allowable closed loop error. Just make sure that you didn't modify that and make it too large, that it is 10 degrees before it tries to make any correction.
Yeah, I think we changed that down too.
There might be also an instance where, and I'm not mechanically blessed, but something your module is too tight where you can't freely rotate it well with your own hand to the point where you're making your PID loop run really hard. Whereas if you just loosen the module so it can rotate freely, maybe you might not need those other elements. We've had that with one of our wheels where at one point we had to we had 4 PID loops and then only 3 of them worked just fine, but one of them you really had to crank it up, but we noticed that it was just a mechanical issue where we had to loosen the wheel, and then it was fine.
Yeah, we basically we had like a patch that we ended up doing where we had 2 PID loops, one for turning to position and then one for like within that 10-degree boundary it switches to a second PID slot where we enabled an I value, but it feels like sort of a hack.
Cool. Well, so I guess somewhat related is so the teams who ran it this year, how'd you feel about driver practice? Like, what did that take? Like, how many hours? Like, did you feel like was the learning curve steeper than like when you first hand a tank drive to somebody, or you see it about the same, maybe more intuitive?
Can you tell me what driver practice is for a second?
Yeah, that's a good question. I mean, that's a good question, right? You throw an intake on a drivetrain. How fast can you? What does it take to pick them up, basically?
Will, you want to comment since you drove this year and you drove tank drive 2 years ago?
Yeah, we did not get very much driver practice, but it was a lot easier to just pick it up and then you're already, left is left instead of having to figure out 2 different sides of the robot and stuff. Although it is so we tried field oriented and then also just normal control, and field oriented is a lot harder to get used to, I've found.
I will share our experience. So our driver last year, he was a senior, so he graduated. He had been a driver the year before, and so he preferred to run robot-centric driving and not field-centric. We did some testing, and we had basically 2 weeks of the chassis functional, And he tried it both ways, but only for one evening and probably only for half an hour, and decided that robot centric was the better way to go. I will say that observing the competitions, I feel like the teams that were using field centric maneuvered the field much better than those that were using robot centric. So we're going to attempt this year to strongly encourage our driver to take the time to learn field centric driving. But in the end, it'll end up being whatever the driver's most comfortable with. I don't think we gave our driver last year enough time, incentive, encouragement to try to learn field centric. And we just said, okay, you know what you're doing. You've driven before. We trust you, robot centric. So I think we're going to put more emphasis this year on trying to be field centric.
The
Although
impression
that's gonna make auto a lot harder, because then you have to know which way you're pointing when you start your robot up.
the impression I've gotten from teams who've run Swerve for a long time is that field centric is a longer learning curve with a higher potential, and robot centric is more intuitive, but maybe a little bit lower ceiling. And that's just anecdotal, from talking to people.
As someone who's really bad at driving robots, field centric was much easier for me. Just from, I don't know why, it just was easier. I think it depends on how much time you spent driving a car, how much time you spent driving cars in video games, right? And how much time you've played different control schemes, right? Whether it's third person, first person, second person games, right? Like, it's mostly mental, right? It's like, if you ever seen videos of people riding bicycles and they have the handlebars geared so they're backwards, right? You can do it, but it takes time, right? And so it as Scott said, right, it partially comes down to what is your driver been used to. And I agree, from watching teams, from what I can tell, once field centric seems to be superior in terms of how you can operate the robot at a top level performance, right? What we ended up, I think we ended up doing where at one point we were going to set it up so that we could switch back and forth mid-match control scheme, right? Which is a dumb thing to do. But we thought about having it just in case you got into a bind. But so I guess my question, Scott, is why were you saying that if we choose to do field centric, it's going to make auto harder?
You're right. We could have switched. We probably would. We probably would do robot centric for auto and field centric. It was something that came up, and I had forgotten that we had actually written code too to be able to allow people to switch using smart dashboard, or whatever, shuffleboard, whatever it's called now. And then I don't know if that code just fell off the face of the earth or what. But I forgot that you could do that. The other thing that you'll have to do if you do field centric is you'll have to have some type of reset button on your driver station so that if you lose power in the middle of the match and you come back online after a reboot, that you can get yourself pointed away from you and then say, okay, now set that as my 0.
Yeah.
If you do pose estimation with April tags, that will help if you use that as your true 0.
Assuming that all the April tags are unique.
Yep.
I'll echo Jason a little bit. As a non-gamer at all, I knew it was different driving the field-centric stuff with the Swerve Drive, but it wasn't a big hurdle for me just because I don't have experience either way, really. And with the SDS stuff, there's a button on your controller where you can re-zero your front of your robot, if you will. It's just the back button, I think. So you can have the corner of your robot be the front of your robot, or any orientation, which is already embedded in their code. So I just, a couple questions. Like, is everybody using a NavX type of module, or are they relying on the RoboRio gyro to coordinate this stuff? Or I'm assuming it's all NavX stuff.
We tried both a NavX and a Pigeon. They both worked well.
We run NavX.
Okay, that's what we're on to. NavX. And then a follow-up. What are you guys using for your controllers? We have it set up for an Xbox type controller right now, but I'd be interested in trying to switch that over to a flight stick thing. What if your team's experienced works good for them?
We use 2 joysticks, and we tried, I guess when we were testing it over the summer, we tried using one 3D joystick. I think the problem with that was that it was hard to turn in place and move in any which direction. So we split it up into 2 separate joysticks, each 2D joysticks. One was for translations, so moving backward, forward, left, right. The other one just had the x-axis for rotating. So you could have one hand for rotating the robot, the other one for actually moving it. That's what our solution was.
And your 3D joystick, the problem was that just finite control because you're trying to rotate and drive at the same time on the same stick?
Yeah. It got a little bit confusing to kind of conceptually think about what you were doing. And also by twisting it or moving it any which way, you could accidentally give input to, without really realizing it. One of the problems was we were accidentally giving input to the wrong axis, like not unintentional input, which made controlling it a little more difficult.
Sure, I can see that. Twisting it and giving it a little bit of forward or something like that to make it difficult. Okay, good. Thanks.
Yeah, I think if you got different joysticks and found some maybe with a larger range and up your deadbands a little bit, you could make it happen. But we went Xbox controllers too because it's so easy for us to slap commands on all those buttons. The other thing that we haven't talked about, but I think is more advanced than we didn't get to, but we really wanted to last year, was rather than robot centric or field centric, was goal centric. Right. So if you're detecting the goal, you can potentially change so that as you drive, so like last year's goal, right? Nice big circle in the middle of the field, right? You could set it up so that when you push left on the stick, your robot circles the goal, keeping its distance from it and its orientation to it. Right, which potentially, if you're playing against defense, is useful. You make a slide over, but without changing your distance, so you can still shoot and not impact that shot as much.
And what did you call that mode?
I called it goal centric.
Okay.
The other ones are all named robot centric because it's from the robot's point of view. Field centric because it's from the field, relative to the field, and goal centric because it's relative to goal. Although I don't know if I made that name up or it's a real name.
No, I didn't catch it when you said it, so I just wanted to make sure I heard it.
Jesse, to your point about the controllers, the big debate, I think it's drivetrain agnostic in that it doesn't matter if you're using a swerve drive or a tank drive or whatever else. But it comes down to fine motor skills with your thumb. Essentially, that's a fine motor skill versus a coarse motor skill with your arm. And what I've found is through both experience and some technical studies done by other teams is that the fine motor skills you've got with your thumbs typically actually outperforms the coarse motor skill, despite the fact that the joystick actually has a larger range of motion than the analog stick on the Xbox controller. The other benefit you have with an Xbox controller is it's a much more natural progression for students who like to play video games. So for me, I'm always going to advocate for an Xbox controller.
Yeah, my current drivers aren't gamers. But yeah, I get the fine motor skills with fine movement with the thumb. Yep. That's totally true, I'm sure.
The Nightcrawlers always use split arcade with 2 flight sticks. And one of the things that we found during Power Up when we decided to build ramps on the side of a robot to do lifting that year rather than doing buddy climbs was that people that were using Xbox controllers were incapable of driving straight because you're making small adjustments as you drive to go straight. And so they were having a lot of trouble driving precise with those Xbox controllers. To Brian's point, if you're a gamer and you're used to playing Call of Duty or whatever and lining up scopes and whatnot, these tiny little movements, you probably won't suffer. But our drivers, especially when we see new drivers, they tend to do better with the larger arcade sticks because they they can be more precise driving because they have larger range of motion. But that's an old person talking, so younger people will probably fight me on that.
I'm of the opinion, Scott, that the overlap in the Venn diagram of teams that are going to be driving onto other teams' ramps and teams that don't know how to set dead bands correctly on their controllers is very high.
It's just a circle, Jason.
Well, no, Ryan, because we're a team that maybe should be driving onto other teams' ramps frequently, and we know how to set dead bands. So,
well, what I would say is that no team should ever build a ramp. Getting the conversation back on track, I do have a relevant question. How many? So I'm coming from a team now with a fairly restrictive budget. We're doing our best to fundraise, but Swerve was a big upfront investment, and we don't have a ton of money. How many modules should I plan at minimum to go into the season with? We purchased 4. I've got the intention to maybe buy 1 more as a spare, but we will not be going in with any more than 5. I guess my question is, how dumb would I be to go in with 4?
That's fine. You'll be okay.
I think you'll be okay. I think you should look at your modules and see what's most likely to break, and most likely it's going to be the mounting plates. You might want to buy a couple extra mounting plates.
Yeah.
But you're probably not going to break a gear. You're probably not going to break a wheel. You're probably not. What's probably going to happen is if you fall on a climb, you're probably going to bend up a corner, and those 2 mounting plates may have to be replaced.
Okay.
So I don't think I'd buy a whole new module. I think I'd buy mounting plates in case one you drop and you get bent.
Okay.
You might even be able to
could-
machine those yourself too. I mean, those mounting plates aren't that complicated, so
Right.
you might even be able to machine some backups yourself.
A spare module you could potentially swap between matches and finals. It might be harder if you have to rebuild one. That's the only thing I would consider. But
Yeah, absolutely.
I kind of agree with Andrew. At the state tournament last year, I think the Gators replaced a whole module between matches. They had to for some reason.
They did. I was right there. They had a can issue, I believe it was, or it was a dead motor, and they hot swapped their entire module. I do agree that is the way to go if you've got, from somebody who's never run a Swerve before. It seems to me that unplugging your motor connections, dropping in a new module, and with the new Rev code, they're going to have the ability to basically make all of the modules interchangeable. With basically USB-C, you plug in, you ID everything, and they're going to be interchangeable. I do think that's optimal from a quick turnaround standpoint. I don't know if that'll be relevant for our team, given our team goals and where I expect us to be competitively. But if we've got the money, I would love to have 5 modules. But it's good to know that we can maybe get away with 4.
I'd definitely get some extra wheels for the Rev ones.
Yep, they're rubber wheels, so we're gonna have probably double the number of wheels that we expect we need.
So I don't know. Based on our experience, I almost think if you know how the modules put together, the time to disassemble and replace the broken part is going to be about the same time as it takes to make the software changes and update the electronics, right? And the vast majority of our failures were electronics based, or it was wires ripped out of can coders, we had to resolder, connectors ripped off of Falcon motors and we had to put new connectors on, right? Other just beating things up and screws falling out and carpet wrapped up in there, right? And so I almost think the time to take something off and keep the same motors if you can, versus the software changes is going to be potentially the same. I don't know those motors, but just something to keep in mind that sometimes once you are mechanically familiar with something, it is so fast to swap it that it might end up being faster.
Good to know.
So, because the other thing it comes down to too is you can get another module, right? But another whole module includes another encoder, another set of gearboxes, right? On the Rev ones, you have to have the planetary right? And then the motors, and that cost adds up to pretty high versus being able to get some additional motors, which I think everyone's seen the motors and the encoders are the things that tend to fail, and the wheels. So depending on where you are on the cash strap nature, Ryan, it might make sense to run the numbers a bit about what you could get there.
Good to know.
It's probably going to be game dependent too. Like if you can't fall from a 4 feet, from a 4-foot bar, then I don't know what else is going to break the modules, right?
I'm terrified of a 2020, 2x1 metal beam that they put in the middle of the field. I think first is learn their lesson in that being a very negative thing for the team experience. I don't think they're going to do it again. But not to say that they could. I mean, I won't put it past them either. Especially with the 3-inch wheel of the Rev module. I know the SDS and all the other common modules are all 4-inch wheel. I'm a little nervous about the 3-inch wheel, just in that, smaller diameter, it's going to have more revolutions. It's going to wear out quicker. If there are beams on the field, it's going to take an impact higher up on the radius of that wheel. And I think that it could create problems. So I'm hoping for a flat field. I'm also expecting a crowded field this year.
That you bring up a good point about wearing out the wheels. Did anybody run Swerve last year and burn through blue nitrile tread like crazy? So we heard a lot of that. We heard a lot of teams saying, "Yeah, we went through blue nitrile like crazy. We never ever replaced treads at a tournament."
Yeah, we were with you, Scott. We didn't replace treads we replaced them before our first competition because we thought, well, we should probably replace the treads, not because we thought we had to.
So what I think the trick was for us, and maybe you did this too, Jason, is we put a slew rate limiter on our joystick inputs. And I think that's what the difference was, is that we just weren't ripping the tread off because we were changing speeds so quickly. We did that slew rate limiter because we were having trouble controlling the robot well. And the slew rate limiter made a lot of our pathing a lot better. But I think that actually ended up saving our tread on the wheels as well.
Or maybe we saw our driver, we gave it the controls to him for the first time, saw him drive it, and we were like, we should probably do something about that.
Oh yeah, that's what it was, because he had just a chassis.
Yeah.
There was nothing else, and he was able to put it up on 2 wheels. And like, if you can put it up on 2 wheels with just a chassis, we have to figure this out. So then we put in a slew rate limiter, and then that's right. That's why we did that. So
I know
the
there
slew
was
rate limiter, I think, saved our tread.
I know there was a bad batch of blue nitrile as well, running out there, and I think we bought all of it. But we switched to black neoprene, and that definitely saved our wear and tear on those things.
Are Sam and I the only two teams that are going in with the Rev modules? Is everybody else on the SDS modules right now?
Yeah, we're SDS.
Yeah, on that note, Ryan, the first thing we did when we got to competition, because we didn't have a set of spares, was we watched the pits and looked at everyone else who had the same modules and wrote them down so we knew who to ask.
That's exactly what I'm getting at, too. It seems like the Rev modules might be somewhat rare at events. Hey, Sam, what event are you going to again?
Lake Superior.
Let's go. Perfect.
See you there.
We'll get you covered if I buy that 5th one.
Sounds good. Same the other way.
Has anybody ever done the passive omni wheel trick for Swerve Drive, or have you heard of that before? Okay, seeing confused looks. Again, never run Swerve before, just through the grapevine stuff that I've heard. Let's say you drop a module in qualification 15, you're in qualification 19. You need to get quick turnaround. You don't have time to fix your Swerve Drive. What I've seen teams do is have a pre-manufactured, basically passive omni wheel that they can bolt in in place of the dead module, and they can drive their Swerve Drive with 3 modules and just have their 4th wheel, exist. But so sounding like nobody's ever done that before. My question was going to be, what was your experience like with that? Did it work well? being that no one's done it, what I've heard is that it's a very viable option if you don't have time to hot swap a module.
I buy that. Yeah, 100% on board with that. We did not build a plan. We had talked about trying to figure out some type of a caster that we could bolt on. Our solution actually was going to be to disconnect the motor, take the tread off, and just run with the slick steel, and so it would
Yeah.
just slide it along the carpet. That was going to be our plan had we completely lost the module with no chance of fixing it. Is just pull off the blue nitrile and slide along the carpet.
Right. My game plan going into the year would be you create a fixed Omni wheel bolt-in substitution for a module. You can get it in 5 minutes. You unplug all the wires. It's just existing. And then I don't know if you need to adapt your code or if the code is going to be with the gyro and everything self-sufficient. I don't know that. But either you adapt your code so you've got a 3-wheel version, or it does it itself. I'm not a programming guy.
Well, I think I could be totally wrong because I know very, very little. But I think on Swerve, occasionally, depending on your rotation, you have one kind of wild wheel that like picks up and spins faster on rotation as you're moving along. That kind of like resets back. Is that true?
I think all wheels work equally, depending on what the control input from the driver is. But Ryan, to your point, I think to make it clean, you just want to like comment out that wheel if you're going to put an Omni wheel in, just so that you're not commanding a velocity to a wheel that doesn't exist.
It's gonna drive a little drunk.
Yeah.
Right.
Well,
because,
better than not driving is the whole idea, right?
Right. Because if you think about, right, if you're driving and you want to twist as you make a curve, that outside edge has to go faster.
Yeah.
And so two of those, and each of those wheels is a different radii from the center of your curvature if you're making a smooth curve, right? And so they're all going to be behaving at different speeds. And that Omni wheel is not going to be putting the same level of traction into the ground, right? And so it's gonna not perform up to spec, and so it's gonna give you lag, right? And so it's gonna impact how you drive. You won't drive as well, but it's gonna be better than not driving or driving with an empty wheel.
Right.
Yeah, you might be better just bolting on a caster, or even I know that a lot of mini robots they 3D print a marble caster where you got a marble that just, and that might be a good option too. It's something that I've been thinking about for our side is, can we just 3D print a marble caster and just have a floating corner?
Yeah. To Sam's point, I think I would comment it out and throw the Omni wheel in there, and just it drives a little goofy, and you maybe want to stick more to driving straight. You know, drive forward, turn, the wheels 90 degrees, drive over, turn, right, and avoid spinning while making curves.
Right.
Right. Act
So
like you're
would you
driving in the
just
snow.
would you just like tell the module and then keep the kinematics the same, keep everything else the same, not setting the state of that module? Is that the suggestion?
Yeah. I don't like changing code to have a backup code because you're never going to test the backup code. Right. So then when you pull the backup code out, it didn't get the last 3 weeks of updates of all the other things you did. So.
Well, it's a quarter past the hour. Does anybody have any things that they want to share before we wrap things up?
Can you guys just whoa. Oh, go ahead. I was gonna say, okay, just real quick, what technology are you guys using for like your autos? Like, are you using like any of the like draw paths, or are you typing in? Do you have, is it all by code by hand, or what's the?
Nightcrawler uses
What's
a
the move?
coordinate. We use a coordinate system where we plot points, and then we use a feed forward solution to get from point A to point B. We don't record our paths, so we don't draw our paths because we want to be able to make tweaks in the pit, or if we have to go another 2 inches this way or another 6 inches that way, we want to be able to just change that coordinate. I think that's called a feed forward solution. I'm probably not using the right words, but we've been doing it the same way for years. So now I've forgotten what the proper terminology is. What does everybody else do for pathing? I'm curious now too.
So this is Team 4859. This is going to be our first year using Swerve, and what we are looking into is characterizing our base. We've done it with a tank drive, and yeah, basically being able to draw a line and have that be our autonomous. Is that the way to go?
Yeah, definitely. Like doing the system ID from WPI-lib and getting the characterization numbers will get you accurate within like 3 inches. It's really nice to be able to use. So highly recommend being able to use those tools like that.
I think we tried to do characterization. I think we ran into some problems. I don't know exactly what, it was a while ago. I don't know if we ended up ever fixing that or if we just went with that.
We didn't end up fixing it, Matt, but we use the SDS library, which is already tuned for the theoretical maximum speed of the Falcons or the Neos you use. So we unfortunately sort of, I can say, avoided it, but we didn't have to do that, and we were still getting really accurate results because SDS had already kind of pre-tuned it in their library.
And I guess if you are using an SDS module, you could in their library to find those. If you're using an SDS module and not the SDS library, I know I've gone all through their library and I'm just finding all their constants and like writing them down. Like those are the ones I'm going to use.
Anyone else have any final questions? That was a great question on pathing.
The only comment I have, not a question, is I would love to have more of these, even if it's specifically on Swerve, but also on different topics. I do think there's an incredible amount of value to kind of a free-flowing discussion like this with a dedicated topic in mind. I think I've had 5 students on here and 2 mentors for my team throughout the call, and I can't speak for them, but I imagine we're getting a ton of valuable information. I know I've learned a lot, so if we're able to do more of these, I think that would be really valuable for the teams involved and the first Minnesota community in general.
I agree, Ryan. And there's already been some discussions about trying to do this sort of on a recurring schedule. With that in mind, anybody want to suggest future topics?
I think a week 1 strategy conversation would be really valuable. What are teams thinking in terms of how they're going to approach the game? I would be happy to contribute to a discussion like that.
I know that we have a rookie team, last year rookie team, that has been sending us tons of questions on pneumatics, and including asking for a shopping list. Is pneumatics a topic that people think there's value in doing, or for those that are already on the call, does that feel like something been there, done that, and not too helpful?
I would be valuable for the students on my team without a doubt.
I think there's a lot of pneumatics tips and tricks that are internal to teams that don't get shared because people think pneumatics are old hat and everyone's done them and everyone knows how to use them. And all the pneumatics discussions are usually just focused on how to make it work and not on how to use them effectively.
I'm curious, one of the tips that Nightcrawler does that we share with all the teams that ask is we have a pneumatics test board so that we can run our pistons without having to have everything wired up on the robot. Do you guys use that strategy where you build a test board with an old compressor and 1 air tank and manual control valves?
Yeah, we've done that in the past.
It's on the to-do list, yeah.
Yeah,
our test is usually we take an old robot and then just manually actuate the pneumatic or the solenoid.
That's cool. Does anyone else have any suggestions for topics? I think these 2 topics have value.
I'd like to see something on wire management. That's something I think the team just can never figure out, and they start a season and say, we're going to do some wire management, but they all look like spaghetti by the end anyway.
I can tell you Nightcrawler will be unable to participate in that conversation. We stick our motor controllers wherever they happen to fit.
Yeah.
It's definitely a positive thing when you go through your inspection process, like having everything nice and neat. They'll actually look at that and say, okay, you guys actually did something good there, just from my experience.
Would you guys be interested in having conversation of things that you've 3D printed for your robot? I know that seems to be something more and more that people we're running into. Last year, we designed our own macadam wheels that we 3D printed that used surgical tubing for the rollers because we wanted macadam wheels that had more grip. So we designed our own macadam wheels that used 3D, or actually it was spear gun tubing. And so that was a nifty trick that I hadn't run into before. I've seen a lot of really cool looking 3D printed parts on robots, but no one seems to ever talk about that.
We use quite a few that other teams have developed on our robot, but yeah, I'd be happy to do that.
We have a new mentor on our team this year who's all about 3D printing carbon fiber. So we'll see what that might do, if that makes it onto our robot this year or not, if we can get our kids excited about something carbon fiber for the robot, because he apparently has a printer that does it well.
One suggestion I have is I do think the 30, well, we're at 33 right now. I think we hit a peak of 35. I think that's a great maximum for a roundtable discussion. And I could see this kind of thing gaining a lot of traction. So potentially breakout rooms and I don't know how much you want to grow this, Scott, or make it accessible to more teams, but I think there's potential here that, a lot of teams could have interest. But if you get too large of a group, I think the value of the content, or at least the value of the discussion between individual teams, would go down a little bit.
Sure. That I agree with that. I really like the idea that we're building community here. In fact, I should have said this earlier. If you want to share your email addresses out, feel free to throw them in the chat here. I don't want to be sending out people's email addresses. I guess you're all in the most of you are on the Google invite, so your email addresses are sort of in the clear. But if you're interested in being a resource, by all means, use this platform to share out your contact info for other people to snag. All right. Well, I think if you my email address, I will say this right now. In fact, I'll put it in the Slack here or in the chat here. Feel free to send me an invite if you want to sort of be added to the permanent invite list to this Google thing. We're going to try to start doing regularly. Scott at team2052.com here. By all means, if you want to get on sort of, I guess it's going to become a mailing list. Throw in the chat here, and then I'll grab those later for the next time we do this. And we'll chat with our teams. You can always reach out to me as well, and maybe this can be sort of a semi-regular thing. I think this was a great conversation. I don't know about you guys, but I was very excited to hear some of the tips and things where people are advising. So that's awesome.
Thank you for putting it together, Scott. We appreciate it.
Yeah,
actually, this was Ken. This is Ken. How do you pronounce your last name, Ken?
Mechtel.
Ken Mechtel's idea. So, and we did this with DNA up in Duluth. I think it was way back in April or May.
Well, there's a lot of desperation for me.
It sort of spun out of control. It was going to be 4 to 5 people, and now look, we had like you said, 35, 37 people. So it was really great.
Hey, Sawyer, Max, do either one of you have any additional questions you wanted to ask?
Not really. Like a lot of my questions have been answered by you guys.
Okay.
Yeah, we're still like
I'm sorry.
Yeah, we're still working on like making the autonomous. Like we haven't gotten to like the autonomous part of our robot, so I wasn't really sure what to ask, and you guys talked about it better than I could have.
No, that's good.
I am also here going to put our GitHub on here. We open sourced our code from last year in June, I think it was. I'm pretty sure github.com FRC 2052 is our hub. So you can go if you're interested to see how we set up our pathing, how we select our auto routines. All of that would be in last year's code.
And kind of going along with that, I feel like if anyone has any like good Swerve resources or documentation or anything, really putting that out would be helpful as well, because it's kind of hard to find. I mean, if you dig, you can find some pretty good examples, but it's pretty hard to find examples on it, from my experience.
Cool. Thanks, guys.
Right.
You really confused me a lot when you kept calling him Ken, because my name is also Ken, so I thought you were talking to me the whole time. So, yeah. Nice to meet you, Over Ken.
Nice to meet you too.
All right. Well, thanks everybody. I really appreciate your contributions tonight. This has been really great.
Thanks. Thanks again, Scott.
Have a good night.
Appreciate it. Very good.
Thanks. Merry Christmas, everybody. Happy
Merry
holidays.
Christmas. Thanks, guys.
Have a good night. Bye.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.